Okay, what works really well here is to think that the mean of a probability distribution is just a weighted mean like we did back in chapter 2, okay? I mean, it is just, there's some twist to it though, but no, not much. So let's see if we'll go back and do a GPA and then we'll do the probability distribution. So in page 26 of the thinkdo book, Dr. Stevens has this example A where he works through the GPA for that set of letter grades, and then they have the your turn. So let's do the your turn. So I know F is 0 points, and A is 4 points, a C is 2. So then what we do is we multiply the credits times the value. See, this is what it's worth, and this is the frequency. So we're going to multiply those. I mean, really be nice to reverse this. So we have where these are the values and this is the frequency, but it doesn't matter because multiplication is commutative. So 0 times 4 is 0, 1 times 4 is 4, 3 times 2 is 6, and of course we got all those three courses the same. And then we find the sum of the products, right? The sum of the products. So what's that going to be? 10, 22. And then we divide that by the number of credits, which is the sum of the frequencies, which is 14. And then we divide 22 by 14. And what is that? That's 1 point something, right? What is it? 1 and 8/14, whatever that is. So it's 1 point something. I don't have a calculator right here, so I can't do that. But that's what we do, and hopefully that's familiar. So how does this translate into a probability distribution? So with a probability distribution, this is from page, oh, I don't know what page it is. Just a minute here. It is from page 71. So what we have here, this is like the letter grade, what the letter grade is worth, and then the probability is like the frequency. So what we're going to do is we're going to multiply x times p of x. What we did just a minute ago, we did w times x, I think it was. So we'll just multiply these things, and let's see if I can do this. Because I don't have a calculator right here, I'm gonna, and hope this doesn't confuse you. I'm gonna rewrite these. These are just eighths: 1/8, 3/8, 3/8, and 1/8. Because those are easier to multiply. So 0 times 1/8 is 0. 1 times 3/8 is 3/8. 2 times 3/8 is 6/8. And I'll actually leave it in terms of eighths. I won't reduce it. And 3 times 1/8 is 3/8. Then, remember how we had to add up the products? So let's add up these products. Well, let's see, 1/8 or 0. Let's see, 9/8, and then 3/8 more is 12/8. So we have 12 over 8 for the sum. And then we're going to divide that by the frequency. Now, the frequencies were the probabilities. Well, this is a probability distribution. We know this in order to be a probability distribution, the sum of the probabilities has to be 1. So we're really dividing that by 1. In other words, we don't have to divide. All we got to do is do the multiplication, add them up. That's it. So what is this as a decimal? 1 4/8 is it? So that's 1.5. So what does that mean? That means the long run number of heads, average number of heads we can expect to get when we flip three coins is 1.5 heads. Okay, so that's what the interpretation of this the expected value is. Okay, it's the long run average. Because you don't know what can happen, right? We could take 3 coins. Well, I guess they're flipping a single coin, but we could take 3 coins and flip it, and we could get all 3 of them be heads. We could get all 3 of them be tails, or some variation in between. But in the long run, it'll be 1.5 heads on average. Okay, I know we can't get 1.5, but 1.5 heads, but that's an average value. Okay, so hopefully that bringing it back to weighted means helps you do this.